Welcome to this in-depth tutorial on mastering React component performance. In today's fast-paced digital world, delivering smooth and efficient web applications is more critical than ever. Imagine your users navigating through your app with seamless transitions and lightning-fast load times. Sounds ideal, right? That's exactly what we're here to help you achieve. By the end of this video, you'll have a strong grasp of optimized rendering techniques and efficient React profiling tools that will elevate your applications to new heights. You'll learn how to tackle one of the most common challenges in modern web development: performance bottlenecks in React applications. As your app scales, inefficient rendering can lead to slow user interfaces, frustrated users, and potential revenue loss. Understanding and addressing these issues is not just helpful, it's essential for maintaining a competitive edge. We'll explore the core concepts of how React renders components, delve into real-world applications, and guide you through advanced optimization patterns. We'll also highlight common pitfalls and share expert tips on avoiding them, ensuring your React applications remain performant and user-friendly. Finally, if you find this content valuable and want to stay ahead of the curve with the latest React tips and tricks, don't forget to subscribe to our channel. By subscribing, you'll get access to a wealth of knowledge and stay updated with all the latest tutorials that can significantly benefit your development journey. So, are you ready to take your React skills to the next level? Let's dive in and transform your understanding of React component performance. In the world of web development, React stands as a beacon for building user interfaces with its component-based architecture. Imagine constructing a building with modular blocks, each block representing a component. This analogy helps us understand how React's components work together to form a cohesive application. However, as the complexity of an application increases, akin to adding more stories to our building, ensuring that each block or component performs efficiently becomes crucial. At the heart of React's performance optimization lies the concept of rendering. Think of rendering as the act of painting a picture. You want to ensure that only the parts of the picture that need updating are repainted. React achieves this through its virtual DOM. The virtual DOM is like a sketchpad where changes are made before applying them to the real canvas, the actual DOM. This minimizes the costly operation of direct DOM manipulation. Another critical aspect of React's optimization is reconciliation. It's the process by which React determines which components need to be updated. Imagine having a list of tasks. Instead of going through the entire list every time you want to update one task, reconciliation allows you to focus only on the tasks that have changed. This efficiency is achieved by comparing the current and previous states of the virtual DOM. Understanding component lifecycle methods is akin to knowing the stages of a plant's growth. Each stage, like component did mount or should component update, offers opportunities to optimize how and when components render. For instance, should component update acts like a checkpoint, allowing you to decide whether a component should re-render based on changes in props or state. When we delve into the terminology, pure components are like pure functions in mathematics. They return the same output for the same input, which helps prevent unnecessary re-renders. Memoization is another powerful technique, akin to taking a snapshot of an expensive calculation. By storing the results of these calculations, the application can quickly retrieve them without recalculating, similar to recalling a formula rather than deriving it each time. Batched updates are another optimization strategy. Picture a mail delivery service that gathers all letters for a particular area and delivers them together, rather than one by one. React batches state updates to minimize re-renders, enhancing performance by processing multiple updates in a single go. The React ecosystem provides tools like React DevTools and the Profiler API, which are like diagnostic tools for a car mechanic. They offer insights into how components are rendering and help identify where performance issues may lie. These tools are indispensable for developers aiming to fine-tune their applications. In real-world applications, such as an e-commerce platform, the performance of React components can significantly impact user experience. Slow rendering can be like a long queue at a store, frustrating customers and potentially leading to lost sales. By employing optimized rendering techniques, developers can ensure that product lists update swiftly and cart interactions remain smooth, much like a well-oiled machine. A practical example involves using React's memo and useMemo hooks to prevent unnecessary re-renders. Consider a product list component that renders numerous items. By memoizing the rendered products, developers ensure that the list only re-renders when the actual data changes, rather than on every component update. To implement these optimization techniques, we start with setting up a React application using Create React App, a tool that simplifies the initial setup, much like laying the foundation for a new building. From there, developers can install necessary dependencies and tools like React DevTools to dive deeper into profiling and performance analysis. Creating an optimized component involves using memoization and pure components. For instance, an expensive component can be wrapped in memo, ensuring it only re-renders when its data changes. This approach is comparable to using insulated materials in construction to maintain energy efficiency. The Profiler API allows developers to measure the rendering cost of components, providing a detailed breakdown of rendering times. It's like having a stopwatch to time each segment of a race, identifying where improvements are needed. By running and testing the implementation, developers can use React DevTools to analyze performance, much like a driver testing a car's performance on a track. With these tools and techniques, React developers can ensure their applications run smoothly and efficiently, providing an optimal user experience. Let's begin by examining the main application file, which coordinates the rendering of our optimized components. This file is crucial for setting up the profiler and integrating our expensive component, using techniques like memoization to optimize performance. Next, let's explore the expensive component file. This file demonstrates the use of React.memo for preventing unnecessary re-renders and contains logic for computing values that might be performance-intensive. Let's conclude this section by looking at the package.json file, which includes necessary dependencies and scripts to run our React application. This file is essential for configuring our project's environment and dependencies. In this demonstration, we begin by navigating to a web application designed to showcase optimized React components. Upon arrival at the app interface, we interact with a button labeled to answer affirmatively, ensuring that the initial setup is acknowledged and any necessary state is properly initialized. Following a brief pause to allow the interface to stabilize, we proceed to engage with a button labeled Increment. This action demonstrates the responsiveness of the component, showcasing how efficiently it handles state changes and updates the UI. After observing the immediate effects of our interaction, we simulate a user action by scrolling through the page. This step emphasizes the seamless performance and fluidity of the UI, even when handling potentially resource-intensive operations like scrolling. Another brief pause allows us to confirm that the page adjusts gracefully to user input and that performance remains consistent. To further illustrate the efficiency of these components, we once again interact with the Increment button. This repeated action underscores the component's ability to maintain high performance under multiple interactions, reflecting the effectiveness of applied optimization techniques. A final pause provides an opportunity to verify that the application continues to perform at an optimal level, reaffirming the stability and responsiveness achieved through these advanced React rendering techniques. As we've explored today, mastering React component performance isn't just about writing code. It's about adopting strategies that make your applications more efficient and responsive. By optimizing rendering techniques and utilizing powerful profiling tools, you can significantly enhance the user experience and ensure your applications run smoothly even as they scale. These skills are not only vital for creating high-performance applications, but also for your growth as a developer in an ever-evolving tech landscape. Now that you've gained these insights, consider implementing them in your next project. You'll likely notice a substantial difference in how your applications perform, and your users will thank you for it. If you're eager to continue enhancing your skills, make sure to subscribe to our channel. We focus on delivering real-world examples and practical guidance to help accelerate your learning curve. By subscribing, you'll gain access to a wealth of knowledge that can transform your development process and elevate your professional journey. Stay ahead in your React development journey with us, and let's continue building exceptional applications together.